Welcome back. Now I'll be doing a few of these selected solutions to the Dynamics Worksheet 4A, which you find in the Compass link. So just to get you started, we'll do the first couple together and then I'll let you go off, and then I might do one of the harder ones towards the end. So question 1 says a skier of mass 85 kilograms is skiing down a slope which is inclined at 35. The snow is offering no friction resistance. So we're going to calculate these three things: the normal reaction force, the component of the weight force acting down the slope, and then the acceleration of the skier. So in always doing these things, now we don't have to do much with this, this work. We can just simply use the following formulas. We know that we've got a slope which is there and at an angle of theta, and we know that the normal reaction force N is counterbalanced by a force down here called mg cos theta, and we know the force down the plane is mg sine theta. So we can do this everything here by just formula, actually. We don't have to resolve these each time. We're not required to do so. So the first thing is we want to find the normal reaction force. So 1A, the normal reaction force is equal and opposite to mg cos theta. So adding all the information in we want, it's 85 kilograms times 9.8 times cos of 35. And just getting my calculator, popping that in, we get 85 times 9.8, oops, not 92, 9.8 times cos 35. And then the normal reaction force would be 682 we'll go to 0.4. So it's 682.4 newtons. Okay. The second thing we had to do, which is, that's part 1. Part 2 was asking to calculate the component of the force down the slope. So that's this one here. That's mg sine theta. That's the one that we're asked to do. So the component, this is the unbalanced force. That force would equal mg sine theta, and that would be 85 times 9.8 times sine of 35. Once again, just calculating that. Getting some light onto that calculator. That's 85 times 9.8 times sine of 35, and we get 477.8 newtons going down the page. I'm not saying down the page, down the slope. Now, with the third thing we're asked to do is find the acceleration. This here is the unbalanced force. So that there, being this force going down here, if it has no friction against it, it just becomes an accelerating force down the slope. So it would equal ma, so the force down the slope, F equals ma, and therefore 85 times the acceleration, that's ma, is equal to 477.8. The acceleration will be this value here divided by 85. So it's 5.6 meters per second squared. Okay. We could also, if we know that we're going directly to the acceleration down the slope, we could just simply say, therefore, ma must equal mg sine theta. The m's would cancel, because you'll notice that the 85 is appearing here and also over here. That means the acceleration down the slope is called g sine theta. So if you know you're wanting just to go straight to the acceleration, you could simply use that as the acceleration down the slope. Let's try question 2 together now. So question 2, looking at it. Question 2 is a 22 kilogram block sits on a smooth ramp at 28 degrees to the horizontal, and we're going to find, once again, the weight force acting parallel to the incline. So we just got to interpret what that means. calculate the force acting on the block by the surface. We should be able to interpret that, and then calculate the acceleration of the block down the incline. So once again, let's have a look at what we've got. I should actually get a diagram, which I'm not going to constantly draw over. But anyway, this force is the normal, and that is equal to mg cos theta, and the one down the plane is mg sine theta. These two are in balance, that equals that, but this one is the accelerating force down the plane. So the first question here, calculate the component of the weight force that is acting parallel to the plane. So the weight force is mg. So we're looking for a force which is mg, and it has to be parallel to the plane. So here's the plane, and there it is. Mg sine theta is the weight force parallel to the plane. So that's what we're finding there. So for 2 part 1, we're just wanting F equaling mg sine theta. I'll let you calculate that one. Question 2 is asking us what is the force acting on the block by the surface? Well, the force acting on the block by the surface is a normal force, so we want this one here, which is N equals mg cos theta. Remembering we know m in both cases, that's 22, and we know theta in this case is 28. So that's 22 there, that's 22 kilograms, and that's 28 degrees. Okay. And finally, the third thing we're asked to do here is the acceleration down the plane. So number 3, acceleration down the plane. Now you could simply use this value over here and make it equal to ma like we did, or you could use a equals g sine theta like we did before. Okay. I'll give you a go at I'll let you go and have a go at the rest of these ones on this page. Okay. So just having a quick squiz, making sure that there'll be no problems. In question 3, you're asked to find the force that must be applied parallel to make it to hold a mass not moving down the plane. So in other words, we want to find a force that will stop it from moving, and obviously it has to be equal and opposite to mg sine theta. And question 4, we have to do the same thing again. What is the one that is acting up to make the mass be at rest? And then all these others are simply trying to work with different aspects of what you do know and how to calculate them. So have a go at doing the rest of that sheet, and I'll come back with some extra ones at the end. Thank you.